All right, guys, we're ready to roll here. Coach Dell, hope you're all doing well. I tried to get a special guest in this one today, but apparently he decided to go yell at the leaf blower next door, so he's a little sleepy right now. Reggie, say hi to everyone. So we were trying to get him to help out today, but he's a little tired. So we're going to rock and roll here. You guys are doing a phenomenal job, by the way, submitting stuff and getting it all in. Pretty pumped about this whole YouTube thing right now. So let's get ready to roll. All right, so here we go. The next one we got exponential functions. All right, so the big thing is when we write exponential functions, they have to be written in this form, that y equals a times b to the x. Okay, x is an exponent. So now here we go. We're starting to venture into the non-linear categories. So we've talked about linear functions, exponential functions. Those are the two that we got now. In particular, we're starting with exponential growth, which happens to be represented by this equation. So here, in the previous part that I showed you, is what b is. B is this number, 1 plus r, okay? Now, that first number, A, is the y-intercept, the initial amount, all right? So when we start moving into word problems and things like that, it's the initial amount that we start with, okay? This here, because this is exponential growth, keep in mind, see how it says 1 plus r, plus growth, all right? It's known as the growth factor. So whatever this number is, after we add the 1 plus r, the number we get, b, right? That is called a growth factor in this case. R is a percent as a decimal. All right, so the number that we're going to plug in for r is going to be percent as a decimal. X is always going to be time. All right, so if you recall, when we talked about absolute value functions, ooh, I missed one. Linear, exponential, absolute value. This is our third function we know. Absolute value functions, all right, had a parent function that we relate everything to. So here are the parent functions for exponential growth. Notice, curve now. All right, so it can either curve up if it's positive, curve down if it's negative. So the y values are increasing, growth. This year, they're going more negative, still exponential growth, though, just in the negative form because that sign. Now, as we get to our graphs, you'll notice this gets closer and closer. It'll look like it almost touches the x-axis, all right? But not quite. And that's because these exponential functions have something called an asymptote, all right? It's an imaginary line that the graph gets closer and closer to but never touches. So in this case, for these functions, we refer to the x-axis as an asymptote. When we go to graph them, the y values will now have a different pattern, okay? These y values, for linear functions, we're adding and subtracting. For absolute value functions, they mirrored after the vertex. For exponential functions, the y values will have a multiplication or division pattern. And when we graph them, we're always going to need an x and y chart. And we know the three most reliable numbers. All right? Dotori, I know you're listening. The three most reliable numbers, -1, 0, and 1. That's what we're going to go with. Dotori, you better be paying attention. Now, as we keep going here, those three numbers are what we're going to plug in when we go to graph. Because we're focusing on exponential growth, the y values will have a multiplication pattern. So growth, multiplication. All right, we know what domain and range is. Hasn't changed. I just keep bringing it up. So here we go. we're going to write the exponential growth equation given this chart. All right, so we know, here we go, exponential growth. It's exponential. We're going to need this key part because it's a y-intercept, an initial amount. And it's exponential. Exponential growth. Notice the pattern here in between each of the y values is multiplication. We're multiplying by 3. That's how we know it's exponential, multiplication. That's how we know it's growth, because it's by 3, multiplying by 3. All right? So when we go to write our equation, exponential functions have that formula. Y equals a times b to the x. A is the y-intercept. B is the pattern. Exponential growth, the growth pattern. Final answer. All right, Reggie, cut it out. It's chewing the couch. This is my life, everybody. Here we go. Next, we're going to graph this function now. It's exponential growth. What did we say before? With exponential growth, we always need an x and y chart. We're always going to use -1, 0, and 1. Now when you plug them in, we're plugging these values in as the exponent. Dr. PEMDAS, because of all the operations, tells us exponents first. So we'd have to evaluate that, then multiply. These are the y values that we should get. All right. Flosion, what do you know about Coach Dell having a YouTube channel with math? I know. I'm coming. I'm coming for you, I'm coming for you, Flosion. More viewers than you, Flosion. Here we go. When we go to graph this and we plot it, we know exponential growth should be a curved function. So when we graph it and we plot them, make sure you make it curved. This is what it should look like. Our x values, -1, 0, 1. A little off the screen, but it's there. Okay? Now, right now, you should push the pause button. Give it a try. All right, you should be hitting the pause button. And again, hit the pause button. Give it a try. Notice here that asymptote idea. Yes, it looks like it's touching. If I kept zooming in and zooming in and zooming in and zooming in, though, it would look similar to what this area looks like, where it's not touching. All right? Now, this is exponential growth, multiplication pattern. The actual formula in place of b is 1 plus r. We also have something called exponential decay, which is a similar concept, but now 1 minus r. It's still exponential, so it's still a times b to the x. Notice the way that the function curves now. It does not curve up. The y values are not rising. The y values are not increasing. The y values are decreasing. Same thing here. They are keeping that similar pattern, but because it's a negative, it's like it's mirrored. Everything else is exactly the same, but now because it's exponential decay, the pattern is going to be division. But we will not write the equation as a divided by b to the x. We're going to write it as a fraction in between 0 and 1 all the time. So here we go. Everything's the same. We got this. Don't freak out. We're good. Here we go. We're writing an exponential decay function. Decay. That is still important. It's the y-intercept. How do we know it's decay? We're dividing by 4. Division. It's exponential. Decay, because we're dividing. Think divide, decay, the D's. Still writing it in this format because it's exponential, but here we go. Dividing by a number is the same as multiplying by its reciprocal. Multiplying by 1/4 is the same as dividing by 4. So when we write the equation, y-intercept, pattern. Jackson, how you doing back there? You good? You sure? All right. I still want you to play football. Here we go. We're graphing. It's exponential decay. Wait a second. Coach Dell, that's a fraction. Yes, it's in between 0 and 1. This fraction is in between 0 and 1. When you see something like that, you know that it's decay. When we graph, we still need the X and Y chart. When we plug in, you better use the parentheses. Because if you're boycotting parentheses, you're going to be in trouble. Parentheses around fractions. Still plugging these in as an exponent. When you graph it, it now should be decreasing. Whoop, there we go. Decreasing, like we talked about. Still got the asymptote going on down here. Never going to touch that x-axis. All right. I hope you're all feeling good. I hope you're all feeling good. All right. Here we go. Pause button again. Should be giving this a rock out. Here we go. Pause button again. Should be rocking out. Hopefully you're getting this. If not, you got my email, adelconte, clarkschools.org. Hit up Coach Dell. That's what our graph should look like. So we're good. And now to the last part. There's a specific type of exponential function that we could run into. It happens to be called a compound interest function. All right. So compound interest is exponential. All right. It's just expressed slightly differently. And the reason is because it is representing interest upon an initial amount. Most common bank accounts. All right. P represents our initial amount or the y-intercept. R represents the interest, but it's got to be a decimal. T is the time in years. N is the number of times that it's compounded. All right? Number of times it's compounded. So here we go. Let's look at an example. You deposit $100 in a savings account that earns 6% annual interest compounded monthly. Write a function that represents the balance after t years. So we're just writing an equation now. All right? So here we go. We know it's compound interest. We're going to need that. Here we go. Let's figure out how we got these numbers. You deposit $100. That's our initial amount, $100. That's going in place of P. The account earned 6% interest. Interest, R. 6% as a decimal, 0.06. Compounded monthly, 12 months in a year. Got to go in place of N. How many times it's compounded? Since we're writing a function that represents t years, we don't know the years. Putting the 12 in place of the N. If we were looking to simplify it, divide before we add, parentheses, Dr. PEMDAS. Hope you all are doing good so far. Here we go. Next example. Now, we're going to do a little both. All right? Last and final example. We're going to write a function and we're going to graph them. Okay? Here, write a function that represents the balance after so many years. Based off of our chart. Oh, initial amount. We're writing a function. Our initial balance is 100. We know the pattern here. If we tried to figure out the pattern, we would notice that it is being multiplied by a certain number. That number happens to be 0.01 T, we don't know the years. If we simplify inside there, 1 plus 0.01, boom, we get what's there. All right, so this one, not necessarily a compound interest, but this one is exponential, what was that, Dunford? Yes, exponential growth. Multiplication going on here. All right. Now, we're going to graph the function from part A and from example 5. All right. Now, funny thing about example 5 is it's not here. So, don't worry about example 5. Just worry about the blue line. When you put the blue line in the coordinate plane, all right, we should get what's here. If we were comparing from example 5, and this was the graph from example 5, we would notice that the difference is that our example is earning more money than their example. And that's because the interest per year is higher than the other one. So our increase is going to be faster. Just like the percent that you put in an effort every day. As always, make sure you ask if you got any questions. Email me. Get my YouTube page out there as well. Maybe we can help someone else. And he's sleeping. Take care, guys.